in the next iteration of MCP, you could actually write 2 lines of code to your MCP server, provided the OpenAPI specs, and it's gonna basically build the entire MCP server from the OpenAPI spec. On top of it, we're introducing a new piece to that, which is MCP, that will remove a lot of, and you'll see it. It's gonna take away a bunch of headache, and it's gonna make your life so much easy.
If I was new to this,
Right?
and I don't know Splunk, and I don't know Meraki that well, this makes my job a lot easier.
Oh, absolutely.
Everyone, I'm back with Kareem. Kareem, great to have you back on the show, man.
Thanks for having me, David.
I love this because this is not chit chat. This is a demo.
Yes.
And hopefully, if I understand correctly, you're going to demo configuration of devices using AI.
I'm actually gonna demo self-healing network using AI.
Okay, so you got to show us that.
So we talked about configuration. We talked about configuration drift. You and I are network engineers. Configuration drift is a huge pain. So with the tools that we have today, incorporating some of the AI tools that we are being introduced to, how do we take that, import it, and bring it into our automation skills with our automation skills and have our network fix itself?
I love this because it's a practical demonstration rather than just talking. So take it away.
Okay, so how much do you know of what MCP and what is MCP?
Now, I know what it is, but a lot of people might not. So can you give us like sort of a breakdown, like what it is?
Yeah, MCP is Model Context Protocol. And I want you to think of MCP as basically this hole that you open up in your LLM so it knows about your world. We talked a little bit before about ragging, right? When we rag an LLM, we upload documents to ChatGPT so it knows, and it knows the context of what you're trying to query.
Yeah.
Right? With MCP, when it comes to automation, it allows you to open that little hole into the LLM so you can feed it the data that you care about, and it's going to make the LLM aware of it. So it's an open source protocol. It's a client server protocol where you build a server, you make these tools and that server available in the clients that we use. It could be Claude Desktop, it could be ChatGPT, it could be your own LLM that you're running on your local machine. As long as it supports MCP, it knows of your world.
In some ways, it's similar to an API, right?
Exactly. It's think of it as that's perfect. It's an API endpoint for your LLM.
Okay, great. So we have traditional APIs, but this is like APIs for LLMs.
Yep. And basically, you're creating this API for the LLM to ingest all the data from the different data sources, and it makes it aware of what you're trying to do. And this is where it plays really nicely with network automation.
Yeah.
So when we talk about network automation, we talked about this for like a while, for 5 years ago, right? When we talked about network automation, it's about, having this script, this automation layer on top of your network devices and your controllers, where you basically via programmatically, you're calling these API endpoints, you're creating logic, you're doing something with it, whether it's getting a list of devices from your network, looking at configuration from your catalog, et cetera. You're doing all of that. Now, on top of it, we're introducing a new piece to that, which is MCP, that will remove a lot of, and you'll see it. It's going to take away a bunch of headache, and it's going to make your life so much easy.
You're selling it. You got to show us.
I was skeptical in the beginning, but I'm a believer now. And I'm only touching the surface on this, and I haven't even started yet. So I want you to think of the scenario, okay? You're a network engineer.
Yep.
You're monitoring your network, and you realize typically in an environment in production, you probably have a source of truth somewhere that's documenting all your network, and that source of truth, netbox, or whatever it is that you're using, you're trying to keep your network config to the source of truth. Yeah. And anytime it drifts, you either have to update the source of truth or deny the drift, configuration drift. Well, what takes the network down, our networks down, is configuration.
Yeah.
Now, what if we introduce MCP to the current tools that we have and have the agent itself monitor that, and if it detects a drift when it's not supposed to happen, it reverts back to original settings.
Oh, I like that. So in other words, the AI is monitoring the network.
Exactly. And it's taking action for you, actions that you've taught and you told it available at its service, and it goes back and reverts all of that for you. And this is what I've done. So I'm going to show you a quick demo, and I'm going to show you, once we go through the demo, I'm going to show you what actually is happening underneath the. So we're looking at Claude Desktop. I chose Claude Desktop as my client. They have a really nice LLM that I can use, a model that's really nice, as well as it out of the box it supports MCP, which is the protocol we just talked about that I'm going to be using in my network automation.
Was it Anthropic? Didn't they create MCP?
Yeah. So MCP, the protocol itself is Anthropic's, and Claude is Anthropic's version of model. So when we're looking at this, I brought in a couple of pieces from a Cisco perspective here. We have Splunk. Is, for those who don't know what Splunk is, think of it, Splunk as a massive log server.
Yeah.
And I'm using Meraki Dashboard as my controller that manages my devices. And what I've done is I've hooked up Meraki Dashboard to Splunk, so whenever any events or any changes happen in Meraki, it just pushes that log into Splunk.
Oh, nice.
Now, if you overlay AI on top of that and you use MCP with the log server and with the Meraki configuration, you can actually do that entire cycle where you're monitoring what's happening with your network.
Nice.
Okay, so I'm gonna start the prompt, and before we drill into the fun and cool nerdy stuff, I'm gonna start the prompt with I'm gonna start with this simple prompt here, where I'm gonna ask it, okay, and let's have fun with it. So, your name is Network Pharaoh, and what I want you to do is I want you to look into my Splunk logs, and I want you to look at only the Meraki network where it's coming the alerts from, because I'm managing a bunch of organizations. So I want to specify on the network that I care about, as well as I want you to search for a specific header into my Splunk. So if you and I were doing this manually, we would go into Splunk, log in, do a search query, and we have to exactly pinpoint which index the log is saved in, and then have to do a lot of labor there to get to it. Yeah. And it's, searching learning the Meraki query is not very trivial. Okay, so I'm gonna hand that off to the LLM, and I'm gonna say, okay, do this for me. So notice a couple of things. So it's searching exactly the instruction that I gave it. It didn't find anything. So it actually continues. It says, okay, that didn't come back. It came with an error. So what I'm going to do is I'm going to expand out the search query. So it figured this out on its own.
That's like an agent, right?
Yeah, I didn't have to tell it anything. Look, I just said, go do it. It did those parts that we would be doing as humans for us. It kept going. It used some of the tools that's available to say, okay, in Meraki instance, I have this list of indexes that I came back with, and voila, finally, after trial and error and tried different things in my search query, it came back and said, yep, I found exactly what you're looking for. Here's the JSON payload and the response from my Splunk instance, and it printed out exactly what's happening. So look at this. So Network Pharaoh, here's your latest Meraki. It got that wrong. The instruction was that the AI is called Network Pharaoh, not me, but we'll ignore that. And so if we're looking at this, it listed what's going on with my Meraki network from a Splunk alerts. It told me that as of today, 12:46 p.m., these are the configuration. There's some settings that have changed, and I've changed them, the IP addresses, and I've changed the name of some devices, and it tells me exactly which devices. It aggregated all this data from my Meraki log. So this is simple, because you're going to say, okay, well, this is cool, but this is just me reading logs.
Yeah.
Right? Now, it also summarizes.
But if I was new to this,
right,
and I don't know Splunk, and I don't know Meraki that well, this makes my job a lot easier.
Oh, absolutely. Absolutely. And it actually told me if I were to do this in Splunk, and if I can, show you real quick, here's a query that very similar to what the AI has done for us. This is the Splunk query that was returned. Look at this. This is the data.
I'm not going to know. Yeah, if you don't know it.
Yeah, can you?
Yep, exactly.
This is old text, new text, the device. Like, you need to you need to write an elaborate query to get exactly what you want. Okay.
Yeah.
But now that we have AI on top of it, the next logical step that we should do and say is, okay, I want you to tell me side by side what changed in my network and by who. So this is part of what we were doing. Now I'm using Claude as a client to do this, but it printed out a nice report for me.
That is great.
It told me the changes, my configuration changes. It told me who changed them and when, and it gave me a timeline of the changes. It told me these are test cases that I was running against my network. So no, I've done this. This was a demo that I did, a session that I was doing. So I was doing those changes live, and it gave you the switch changes. But this is unacceptable because, this configuration drift should not have happened. We didn't use a source of truth for this. There was no netbox or anything involved. So somebody manually went into the Meraki dashboard and made those changes. When we can't have that because our network is probably now down. So what do? We got to fix it.
Yeah.
Now, in the old days, to fix it, what would you have done? We would have gone into the devices. We would have had to look at the documentation, find out which VLANs were deleted.
What documentation?
Exactly. What documentation? It's probably an Excel file somewhere, right? So it's pain, right?
I love this because someone with your experience or a CCIE, maybe for them it's quicker to go and do it the manual way. But if I'm just starting on the help desk or someone who's new to this, that's a lot of knowledge that you can just pull out very, very easily.
Absolutely. And all I needed to know is the components, right? I needed to know that I can search data in Splunk, and I needed to know that there was an MCP server for Splunk, and we'll talk about what that is in a little bit here. And then I also needed to know that I could go back to make changes to my network via Meraki Dash.
But you could have taught someone to write prompts. Like you can say, yes, some standard prompts to find out what's going on, and they could learn from that. It's much easier to learn that than it is to learn all the APIs and everything else.
Easily done something as, here are 10 prompts that you should use to troubleshoot your network, and copy paste them and have the agent configure it and figure it out.
So you said the problem is now the network, there's been drift. Now we need to fix it.
Now we need to fix it. So I'm going to tell the AI to say, okay, this Kareem Iskander shouldn't have made any changes to the network. What I want you to do is I want you to revert back all those changes for me. This on its own, it's going to know a couple of things. Now, it's not going to go to Splunk to make those changes because Splunk doesn't manage my network. But it's aware that it also has another MCP server that's a Meraki MCP server that allows the AI to access those APIs in Meraki. And so by me telling it this, it's going to go say, okay, based on the analysis and the devices, here's what I'm going to do. And I love this because when we traverse the code, I want to show you this. First of all, it knew that it needs to go get Meraki organization. If you're familiar with Meraki, or if you're not familiar with Meraki, the way that Meraki works is you have an organization. Within an organization, you have your network, and within your network, you have the different devices and network types. Okay, so in order via API, if I was automating this, in order for me to go do it, I have to go find out what my organization ID is by doing one API call, traverse that JSON that I get back, pull out the ID that I care about, do a bunch of if and else statements, and then I have to go from there, find out the network ID, and then from the network ID, I start pulling in the devices so I can start reverting those changes. This AI does not know any of that. It only knows that it has access to get organization. It knows to get networks. So, and it did it. It made those jumps and those logics on its own. So it went out and it got a list of organizations. Next, it looked at the Meraki network itself that we made changes to and pulled the network ID, followed by looked at the devices because it has access to the device IDs and figure out which device the changes need to be revert on.
That's amazing. You got to show us the code in a moment because it's like magic. This.
It's done. Look, so it told me that Kareem's first change was this, and Kareem's final change with this. I've correlated the changes, I've configured, and I made the changes, and it reverted back to what it originally was.
I love this because this is a nice demo of like LLMs and what they powerful are doing.
Yep.
But they can't configure a network.
Nope.
but now you're interfacing it with your, is it Python code or something?
It's pure Python code.
Wow, dude.
And it's easy Python
You're
code.
going to show us.
Okay, so you can see how easy this is and how cool this is. And if I go back, before I show you, dive into the code, if I show you, this was the change that happened. If I refresh my network here, you could see that it actually changed to the previous value that it found into Splunk for us automatically. And it probably changed also the IP address and configuration in there. Now, and this is a super simple, see, it changed all my gateways and my LAN IP address. So this is a super simple example.
It's a proof of concept.
But exactly. But imagine doing this at scale.
Yeah.
Okay, now let's look at how easy and what it is that happened underneath the hood here. So first of all, there are two pieces. We have a Splunk MCP server
For logging.
for logging, and we have a Meraki MCP server. And the way that MCP I mentioned earlier, it does two things. It's a client server. So our client, it was this interface. This was our client. You needed to build a server for the LLM to know of all the tools that it has that it's available to it. So if I look at Anthropic's Claude here, and if I click on this, notice how it's aware of two MCP servers.
Yeah.
Okay. The MCP server for Splunk, it knows that it has all these functions, these tools available for it, which is things like list to index. And if you see when it was correcting itself, it pulled a list of index. It did a query. So there's a search Splunk here. That's how it searched our Splunk. And if we take that and go over to our code itself, and by the way, I'll share all this code with our audience here. So
It's on your GitHub,
it's
right?
on my GitHub, so I'll make sure the link is there. But if you look at this, there's a couple pieces that are important, and the code is big, but it's simple. There are a couple pieces that are important. There's Fast MCP. This is the Python library that allows you to build that MCP server. Now, once you have Fast MCP, you define your schema, you tell it a whole bunch of stuff that, honestly, I found that MCP server. I just needed to implement it against my instance. But I also needed to edit it a little bit, and I added some tools. So tools are basically the functions that the LLM is going to look for to execute some of the things we ask it to do.
Okay.
And so you see the MCP server is using async. It has multiple ways to communicate from the client back to the server. I don't want to get into so much of that. There's a lot of reading that you need to learn to get started with MCP, or at least write your MCP from scratch. A bunch of MCP servers out there, you never have to write anything from scratch. But the point is,
We're going to take yours.
yeah, you can, or take mine. Absolutely, exactly. You connect your MCP server to your instance of Splunk, and all it's doing from this point on is actually using the Splunk SDK to make those API calls back and forth, and no logic whatsoever. They're simple API calls. Similarly for our Meraki, and I actually wrote this Meraki myself, the Meraki MCP server itself, because there wasn't one out there, or at least I wasn't aware of one. But I want you to look at this. So this is my Meraki MCP. Again, I'm using Fast MCP. I am using the Meraki SDK. I'm doing nothing more than basically what we've been talking to you about from an automation perspective for the longest time, where I'm saying I'm instantiating MCP. It's going to run on this IP address. I'm also starting a new instance of the dashboard APIs. And all I did was I defined the tools for the MCP. And then basically I went and made those tools, those API calls available to the LLM. So get organization. It's a simple, go get me the list of organizations. There's no logic here. This is just a pure JSON dump that's coming back from the API. Get me the networks. I'm not telling it, hey, first you need to get the organization, next you need to get networks. I'm just making it available. It made that decision. It inferenced from my prompt and from its knowledge.
But how does Claude actually know this? Because this is very specific to Cisco knowledge.
It must be trained on those APIs out there. Claude learned from my code that these tools are available, but it has the knowledge of Meraki API.
Because it's out there, it's been trained.
Exactly. And that's the power of having an LLM at your fingertips.
It's amazing to see this. So, Kareem, I'm slow. I have the LLM. How did you have to do something in Claude to link it to this?
Yeah,
what did you have
really
to do
good
that?
question. the simplest thing that I needed to do is in my Claude configuration, in the client configuration, Claude was just an option. You can build your own client. It could be anything, right? In my configuration, I actually had to go specify where the MCP server lives. In my Claude configuration itself, basically I have a JSON here that defines my different MCP servers. It says Splunk with the Splunk credentials, lives in this directory. This is basically how it's executed. So it's executed by running Python. This is the Python file, and this is where it lives via standard IO. That's it. And similarly for Meraki, it's the same.
Is this an online LLM or is it a local LLM?
This is an online ML. If you go download Claude desktop, this is exactly where you're going to go.
Okay, so it's a Claude client, just like ChatGPT client.
Yep.
That's interfacing with the online brains, if you like.
Yep.
That your client has that configuration that links it to your MCP server.
My local MCP server.
And that MCP server has APIs that it's talking to Meraki and Splunk.
Exactly.
Wow.
And it contextualized all of that for the brain that's in the internet.
And the power here is you're using the LLM for what it's really good at, is passing all this data coming back, using its pre-trained model to actually make sense of all that data. Because imagine trying to do this with APIs, man, and then the APIs change.
Exactly, and that's another thing, is API change. What's really cool too, and I haven't done it here, you'll see it in some of my my blogs that I released. In the next iteration of MCP, you could actually write 2 lines of code to your MCP server, provided the OpenAPI specs, and it's gonna basically build the entire MCP server from the OpenAPI specs.
You're going to show us how to do that at some point.
At some point, yes. That's next on my list once I release all of that.
That's brilliant. So people are, I'm sure, the same as me, right? Where can I get this? So your GitHub, which we'll link below.
Yep, and I'm planning a
you got a Cisco U tutorial or blog or something?
Blog write-up on our blogs.cisco.com. I started a new series called the AI Break, where you take a break and play with AI. So that's the blog is coming out. You will see I'm writing a step-by-step instructions on Cisco U on how to implement and do all of this outside of my blog, and that's going to be a Cisco U tutorial. It's going to probably be released in about 2 to 3 weeks from now. So stay tuned for that. Make sure that you check out our social channels. All of that on Cisco Learn with Cisco will all be shared there.
If I follow Learn with Cisco on X or LinkedIn, etc., I'll see these notifications.
Yeah,
right?
all of that posts once the blogs go out, and I will make sure that in my blog you'll have access to all this code.
So for everyone who's watching, I've put links below to Kareem's GitHub and some other places that you can follow. Kareem, this is like one of the best demos I've ever seen, because it's all this theory, talking, but to actually see it, I mean, that's what counts.
It's really cool. I'm super excited about it. I think there's a lot of I get excited when there's innovation, and there's a lot of innovation that could happen here, and you see it. And this was not hard at all. If I do it, anybody can.
Yeah, not all of us, but I love what you've done here. I mean, it's brilliant. Thanks so much, man.
Thank you.
Appreciate it, man.
Thank you, David.